Hello, today's webinar for North Dakota Post Adopt is titled Dying for Food. First, a little bit about me. My name is Bailey Kitco. I am a licensed social worker. I am the Fargo Region North Dakota Post Adopt Coordinator, and my contact information is provided on the slide. If you ever need me, please do not hesitate to reach out. So here's what to expect from the webinar today. I'm going to start off with two videos. The first video gives an overall look at gut-brain connection, and then the second video really hones in on the mechanisms of how they communicate and how what we put into our body may affect our behaviors. Then I'm going to look at what it is we are and are not feeding our children that may be having effects on adverse behaviors. I'm going to touch on ADHD, and then I'm going to dive deeper into food dyes. So looking at this, it looks like we might be all over the place. However, I put this picture of gears on this slide because although each gear is separate, it's all connected. And I think that's important to remember with this topic because I don't think we can talk about food dyes and the adverse effects it may have on our children without really knowing how the gut and the brain communicate, and without knowing what it is we are or are not feeding our children. So I hope you enjoy. I do have a disclaimer. This webinar should not be used as a determinant for a treatment option for your child if they are diagnosed with ADHD or if they are exhibiting adverse behaviors. The intent of this webinar is to provide information on a topic that you may not know much about. So please do your own research and contact your doctor to make an informed decision if you are wanting to change your child's diet due to their behaviors. The next slide is the first video. There is a 30-second lag that I was not able to trim off. So if you click the slide, I believe the video should be able to start. Also, the sound is a little muffled, so you may want to turn your volume up.
Where we sit right now in history is right at the cusp of a complete paradigm shift in how we think about mental wellness. If we had a problem that we perceived here, it seemed like it made sense that it was in the brain and we should target the brain. And that's what we've been doing for the last 100, 200 years. What we're realizing realizing now is that maybe that isn't our primary target. And what we're seeing here in the brain is a secondary effect of something else that's happening in the body. And what we've just learned in the last 5 to 10 years is that, yes, that is a secondary effect. The primary effect, and therefore the primary target, is in the gut. That's the second brain. That's where we have 100 trillion bacteria in our intestines. That number is more than there are stars in the galaxy, in the Milky Way. So the gut microbiome makes more serotonin than the brain does. That's the feel-good neurotransmitter. It makes more dopamine than the brain. In order for these neurotransmitters in the gut to have their effect in the brain, they have to be able to communicate with each other. And they do that through chemicals that the gut makes, chemicals that the bacteria make, that travel throughout the body, that signal through the nervous system, that signal through the immune system. This idea of the gut-brain axis, targeting the brain, but targeting the second brain in the gut, and then targeting the communication network between them, that axis, that's really the forefront of medicine these days, and the forefront of science, and the forefront of how we're going to actually get ahead of all these mental wellness issues and have it benefit people's lives.
Research shows that the gut microbiome affects a lot of how we experience our daily lives. Emotions, weight, brain functioning, even our food choices. But how does it work? The gut microbiome is a collection of trillions of microbes, or microscopic organisms. These microbes, like bacteria and fungi, live in your digestive tract, mostly in your large intestine. Digestion is just your body taking raw materials, food, and turning it into something it can use.
Nice crust.
Digestion makes glucose, which runs your brain and muscles. It also enables your body's messengers, like hormones and neurotransmitters. Your digestive system is a factory for turning food into fuel, and your microbes are its workers. And what you get out of it depends a lot on the quality of what you put into it. Gut microbes have their own genes, which affect the way your human genes act. There are about 20 to 25,000 different human genes that make up your body. Sounds like a lot. But there are millions of different microbe genes inside of you that influence how your human genes act. In some studies, the microbiomes of healthy mice were transplanted into stressed mice. The stressed mice then showed fewer anxiety symptoms. Fruit flies with particular bacterial species in their microbiomes ate more protein. When researchers changed the flies' microbiomes, the flies ate more sugar. In one study, researchers found that many elite athletes have a group of bacteria that helps break down lactate and could help performance and recovery. When these bacteria were transplanted into mice, the mice's treadmill performance increased. And this is all great news, because you can't change your genes, but you can change your microbiome for the better. And one of the quickest ways to do that is through food. There are immeasurable other factors that influence your gut microbiome: where you live, sleep, exercise, stress. But what your body makes and what kind of microbes your gut has depend a lot on the food you eat. You can change your microbiome and potentially your daily experiences and long-term health through food. Recent technology makes it possible to test your gut microbiome at home to get a peek at what's living inside you. But is gut microbiome testing worth it? In the next episode, we'll take a look. For the Washington Post, I'm Mary Beth Albright.
So just to recap on those videos, your gut and your brain, the gut-brain connection or the gut-brain axis is able to communicate with each other through different pathways. And you can think of the GI tract as the factory and the microbes as the little workers in the factory. And so how you build your microbiome is through the foods you eat. And so a healthier diet would contribute to a more diverse and a more healthy microbiome versus an unhealthy diet, which essentially leads to a less diverse and less healthy microbiome, which in turn can affect your moods. So some other little tidbits here about the gut-brain connection are that the brain constitutes 2% of the body's weight, but consumes 20% of the energy that our body uses. So if you think of food as fuel, it would make sense that a cleaner or whole, healthier diet would help your body function more smoothly. As you see here, serotonin is a neurotransmitter that helps regulate sleep, appetite, mood, and pain. And so if you jump over to the side with the stomach on this slide, you see that 95% of serotonin is produced in the GI tract. And they talk about that in the video, that our feel-good neurotransmitters, dopamine and serotonin, are produced. More of it is produced in the GI tract than it is in the brain. So surface level, it seems to make sense that a healthier diet would contribute to a healthier production of serotonin and dopamine. So if you jump back over to the brain side of this slide, you see that there are 3 pathways of communication between the gut and the brain. So the little workers, the microbes, are able to communicate through 3 ways. And of course, this is much more complex, but for the sake of time, we're just going to break it down to the 3. So it's immunological, so through the immune system, through the endocrine system, so using hormones, and through the nervous system, more specifically the vagus nerve. And so when I talk about food dyes later in this, we're going to focus pretty much on through the neural pathways. The stomach is also called the second brain, and that is because the enteric nervous system that is located in the GI tract is a system of neurons that extends from the esophagus to the rectum. And when the vagus nerve, so the pathway between the two, between the gut and between the brain, when that vagus nerve, when that pathway is severed, the enteric nervous system is capable of organizing and initiating its own reflexes to continue functioning, to continue for the digestive system to function. And so that is why it's called the second brain, is because it essentially can function on its own. There are 100 million nerve cells in the GI tract. And the term gut feeling also comes from the signaling between the brain and the gut through the vagus nerves. So what happens is vagal signals traveling from the gut are thought to be responsible for the pit in your stomach feeling, which acts as a signal to the brain that an environment may be threatening or anxiety provoking. So if you think about children in foster care, children who have been adopted, children who have experienced trauma, a lot of them have GI issues. And this could be because of these vagal signals being in constant firing between the gut and the brain. So more microbiome fun facts include how your microbiome's built. So it makes a difference if a child is born vaginally versus surgically. So as a newborn passes through the mother's birth canal, good bacteria is passed from the mother to the baby. So They've done studies on this, and it shows that babies born surgically have a less diverse and essentially less good bacteria in their microbiome versus babies who are born vaginally. The studies also show that those babies born via C-section can build their microbiome through skin-to-skin contact. But again, if you think of some of our kiddos who come into foster care and who are adopted, some of those kiddos don't get that skin-to-skin contact. So essentially, their microbiome, they're not able to build a healthy, diverse microbiome as, say, a child who was born vaginally and not removed from their mother's care right away. Some other factors that influence a newborn's microbiome include maternal stress, infection, and obesity. And it's really interesting because a person's microbiome is created within the first 1,000 days of their life, so essentially the first 3 years. So what we're feeding our children at a young age is important. It's the foundation of a healthy microbiome in their gut. And as we progress through this PowerPoint, and when we talk about what children are eating, you'll see that a lot of younger kids, toddlers 3 and under, are ingesting a lot of sugary drinks, which are not contributing to a healthy microbiome. So as we discussed in the prior slide, what you are feeding your children at a very early age, and even on, is important because, as we learned, you are able to build and change your microbiome through the foods we eat. So that's a very optimistic and good thing. But right now, what American kids are eating is contributing to a less diverse microbiome. So there was a national survey completed in 2021. It was a questionnaire that was sent out all across the nation, and it was completed by parents, so it was a self-survey. And it was found that nearly 1 in 3, so a third of these children ages 1 to 5, did not eat a fruit within the week prior to this questionnaire being completed. Nearly 1 in 2, so half of these children, did not eat a vegetable in the week prior to this assessment or this questionnaire being completed. What they did find, what they were ingesting, was that 57% drank a sugar-sweetened beverage at least one time during the week prior to this questionnaire. And what this questionnaire, what the statistics found was that the percentage of children who did not eat a daily fruit or a vegetable but were ingesting these sugary drinks were ages 2 to 5, Black, or lived in households with limited food sufficiency. In North Dakota, 325 participants completed this questionnaire, and what they found was that 32, so pretty much the same statistic nationwide, was that 32% did not eat a vegetable did not eat a fruit within the week prior to completing this questionnaire, and 44% did not ingest or eat a vegetable within the week prior to completing the questionnaire. However, 63% did drink a sugar-sweetened drink. So North Dakota actually has a higher percentage of these children drinking sugar-sweetened drinks than nationwide. And so what this shows, what these statistics shows, is that these days too many children are not receiving a proper nutrition. They're not eating enough fruits or vegetables, and they're ingesting a lot of sugar, which these sugar-sweetened drinks contain food dyes, which we'll discuss more in the next coming slides. So now we're gonna just gloss take a look at ADHD pretty quickly here. And why I'm bringing up ADHD is because a lot of the studies that we'll discuss later in this PowerPoint talk about food dyes and the effects it has on children diagnosed with ADHD, because a lot of parents were seeing that when their children who are diagnosed with ADHD were ingesting foods with food dyes, their hyperactivity would increase, maybe their impulsivity would increase. And so a lot of the studies have been done on children diagnosed with ADHD and the effects and the intensity of the behaviors that are exhibited after they eat food with food dyes. What the studies show is that children, even that are not diagnosed with ADHD, their hyperactivity and the adverse behaviors increase as well after ingesting food with food dyes. So that is why we're looking at ADHD. So just quickly here, 62% of children between the ages of 2 and 17 take medication for ADHD. 47% of children between ages 2 to 17 receive behavioral treatment. And 6 in 10 children with ADHD have at least one other mental, emotional, or behavioral disorder. The chart here breaks it down between boys and girls who are taking ADHD medication and their ages. And these numbers are back from 2016. So you can see here that 6.1 million children in 2016 were diagnosed with ADHD. So of those 6 million, 2%, or 265,000, roughly around, are aged 3 to 5. 10%, so 2.4 million of the 6 million, are ages 6 to 11, and 13%, or 3.3 million, of the 6 million diagnosed with ADHD are between 12 and 17 years old. So the annual societal cost of ADHD in children and adolescents is between $44 billion and $64 billion, and that was in 2015. And so concerns about possible associations between synthetic food dyes and the exacerbation of symptoms of ADHD ended up prompting research and reviews. So the percentage of children and adolescents diagnosed with ADHD has increased over the past 20 years. So while other factors may put a child at risk for ADHD, some doctors say some of the risk is susceptible to children through interacting exposures to substances in the environments, which would include foods. So this is kind of what prompted some research and studies on the effects of food dyes and nutrition and ADHD symptoms. Research does not show that diet is a causation of ADHD and adverse behaviors. There have been no studies done that can prove that. However, research and the data does show that adverse behaviors and symptoms of ADHD may be lessened through dietary changes. So through omitting specific foods like processed foods and food dyes and adding more whole foods. And it is important to remember that dietary changes may not lessen symptoms or adverse behaviors for every child. So research shows that it works for some, but it doesn't work for all. And then one should not think about eliminating food or lessening food from a child's diet, but rather providing more whole, healthy foods. And so when I use the term synthetic food dye and food dyes, I'm going to be using those interchangeably. And I'm referring to the 7 most common food dyes used in American foods. This gentleman Benjamin Fangold was a doctor and chief of allergy at Kaiser Permanente. He is kind of the pioneer in this thought of food dyes and food additives and the exacerbation of ADHD symptoms and behaviors. And so Dr. Fangold kind of caused some controversy among the medical field because he based this hypothesis on observation of his patients. And so what he suggested his patients do is go on a restrictive diet, now called the Fangold diet, and that diet basically omitted additives and food dyes. And Dr. Fangold will claim that 30 to 50% of his patients saw improvements after going on the Fangold diet. However, there's no data out there to confirm this. What this hypothesis did generate was attention that the US FDA and others in the United States and abroad it generated so much attention that they sponsored research into this issue. And so these studies are hard to do and expensive, but several have been conducted. And once the results came in, other scientists and organizations convened workshops to review the findings and conduct meta-analysis and reviews of the evidence. And so ultimately, through the data and statistics, government regulatory agencies in the United States, in the UK, and the European Parliament were pretty much drawn into controversy and disagreed on how to move forward and what to do with these results. In 2004 and 2007, groundbreaking studies out of Southampton University in England found that food dyes mixed with the preservative sodium benzoate increased hyperactivity in 3-year-old and 8 and 9-year-old children in the general population. Those two studies prompted the EU and Britain to change regulation and display warning labels on their foods that contain dyes. So 2 years after that last study, in 2009, Great Britain asked food companies to stop using synthetic dyes. When those companies didn't stop using those synthetic dyes, the government actually heavily criticized those companies who continued to use them. And now most products in Britain use natural dyes. So the warning label that you see on here is what you would see on a package in Britain if food dye was contained in that specific food. On the right side here, you see a Nutri-Grain, 2 Nutri-Grain boxes. On the left side is a Nutri-Grain box with the ingredients in America, and on the right side is a Nutri-Grain box that's sold in Great Britain. So you see for the US Nutri-Grain bars, they contain red 40, yellow 6, and blue 1. The British bars contain beetroot red, annatto, and paprika extract. So that's what they're using to color their Nutri-Grain bars. And from appearance in this picture, they don't look much different. So this is a chart comparing products that are sold in the US and the same product that's sold in Europe, and includes the ingredients. So you can see here, Fruit Loops contain 3 different food dyes and other colorings, whereas the European version of Fruit Loops does not contain any synthetic dyes. And the other coloring that's included is through paprika extract. Looking at the M&Ms, they contain quite a few. The US version contains quite a few food dyes, whereas the European version contains 1 synthetic food dye. And so that M&M package would come with that warning label that says this food contains synthetic food colorings that may impair the behavior of some children. And so it's just interesting to see going down how many dyes may be included in one product, whereas it's not included at all, or if very little, in the European versions. Now that we've looked at what other countries have done with that data in regards to regulating food dyes, let's look at what the US has done. So the US FDA derived acceptable daily intakes, an ADI, for synthetic food dyes in the 1960s to the 80s. So what an ADI is what the FDA states is safe, how many milligrams is safe to ingest. So those ADIs were based on animal studies that started in the 50s. They're not based on neurobehavioral toxicity, rather they're based on a few older studies of general toxicity, so what it's doing to the liver, the effects it has on growth and metabolism, and cancer. So the ADIs that the FDA set and the safety factors that the agency applied failed to take into account the health risks of infants and children. So the ADIs, it fails to take into account what it does to children because the ADIs that the FDA set are based on long-term animal toxicology studies that don't adequately assess the chemicals, the effects that it can have on behavior. So the FDA's acceptable daily intake for a 35-pound child is more than 15 times the dose that triggered behavioral reactions in another FDA-funded study that used 35 milligrams of dyes per day. So we'll dive deeper into these numbers in a couple of slides. But as far back as 1985, the FDA estimated that the high end, so in the 90th percentile of consumers who were 5 to 12 years old, ingested 150 milligrams of dyes per day. So not the 35 milligrams that they're saying triggered behavior reactions, but 150 milligrams. So that's 5 times higher than the amount used in earlier studies. So while the estimate is probably overstated, it does indicate that the FDA realized that the doses, their suggested dose of 26 to 30 milligrams, were inadequate. The flawed advice on how much dye to test came from an organization called the Nutrition Foundation. So the Nutrition Foundation describes itself as a public nonprofit institution dedicated to the advancement of nutrition knowledge. Quote unquote. It was established and funded by the food industry. So the organization that is setting these limits is actually funded by the food industry, who is putting food dyes in the food that we're feeding our children. So moreover, the amount of food dyes certified per person has more than doubled over the past 4 decades. So what the FDA is suggesting or saying is okay and safe to ingest really doesn't apply anymore because the average American diet has changed so much from the 50s and 60s. So let's take Red 40 as an example. The typical daily dose of Red 40 used in many studies was about 10 milligrams. According to another preliminary exposure assessment by the FDA in 2014, stated that people may be consuming as much as 52 milligrams of red dye in a day. And so some children between the ages of 2 and 5 consume on average 38 milligrams of Red 40 a day. So thus the amount of dye used in those earlier studies is far too low to reflect the amounts of dye that many people consume today. And many scientists are also emphasizing the importance of testing chemicals for neurotoxicity since it is such a sensitive endpoint. We know development of the brain is incredibly complex and known to be sensitive to a wide variety of chemicals. And so testing for neurotoxicity is very much needed when it comes to food dyes and what we're selling at our grocery stores and what our kids are ingesting. In fact, other government agencies such as the EPA routinely require neurotoxicity testing and use the results in their risk assessments. So in light of all this evidence, it's clear that setting an ADI using animal data from the 50s is not adequate, and that the FDA needs to reevaluate the studies and the baseline of what they're saying is safe. Are you fed up yet? So since 1992, FDA's information for the public on dyes has been prepared in partnership with the International Food Information Council, the IFIC. The IFIC is sponsored by major food companies, many of which use food dyes and some of which are members of the Food Dye Trade Association. As we discussed on the prior slide, the advice given to the FDA from the Nutrition Foundation on how much dye to test to set the ADIs for Americans was also funded by major food companies. So essentially, the information that the public is the information that the FDA is providing to the public and the advice on setting the ADIs for the American public is all backed by major food companies. So now that we've looked at how the FDA came up with their ADIs, let's look at this chart on the broken down milligrams of each food dye and what they're saying is safe to ingest. So if you look at this graph here, it breaks down how many milligrams of each dye is what the FDA is saying is safe to ingest. And then the very last column here shows what a typical dose used in the studies, what's triggered reactions, how many milligrams triggered a reaction. So what the FDA is saying is acceptable for a 35-pound child to ingest is 560 milligrams a day. But if you look at the last column, you see it took 35 milligrams to induce triggers in those studies done on animals. So what the FDA is saying is safe and what the studies show cause adverse reactions such as liver damage, metabolic concerns, and cancer is much lower than what they're saying is safe for a 35-pound child to ingest in a day. So the FDA said behavioral effects from dyes were not because dyes were toxic to children's developing bodies, but because some children have, quote, a unique intolerance, unquote, to dyes. So in other words, the FDA indicated it should focus on better understanding what makes some people sensitive, not protecting them from dyes. So that line of thinking is embraced by food manufacturers as well, and essentially puts the blame on children and not on the food companies. So by saying that children are intolerant is putting blame on them and not realizing that what the food companies are putting in their food can actually have very serious consequences. So if you see on the right-hand side of this slide is an excerpt from a brochure prepared by the IFIC and the FDA. Remember, the IFIC is sponsored by major food companies. And so this excerpt has not been updated since 1992 and is still being published today. So the FDA's public information about dyes has long been incomplete and also misleading, and also backed by food companies, major food companies. Nevertheless, numerous food dyes, including green 1, red 1, red 2, and violet 1, were banned in the US due to cancer concerns. So this proves that the FDA has said it's okay for food dyes to be ingested or to be manufactured, and then have actually come back and banned them. So green 1, red 2, violet 1 were all banned due to cancer concerns. What's also fascinating is that food dyes have been banned more than any other class of food additive in American foods. So in 1990, the FDA concluded that Red 3 caused thyroid cancer in rats and terminated a provisional listing of them for use in cosmetic and drugs. However, in 1969, the FDA had permanently approved a soluble form of Red 3 in foods and ingested drugs, and that listing remains on the books today. So in 1985, FDA's acting commissioner, Mark Novich, told the New York Times that Red 3 was, quote, of greatest public health concern, unquote. And Red 3 currently represents about 1.5% of dyes used today. So here are some more facts on food dyes. In 1906, the Pure Food and Drug Act, also known as the Wiley Act, instituted the first restrictions on color additives in the U.S. So there are 9 food dyes currently approved by the FDA, 7 of them which we talk the most about in this PowerPoint. Food dye consumption per person has increased 5-fold in the United States since 1955. So that means over the past 50 years, chemical dyes used in foods has increased by a whopping 500%. And so a total of those 9 synthetic food dyes are used by food manufacturers in the U.S. But 3 of those dyes, Red 40, Yellow 5, and Yellow 6, make up 90% of the market. These dyes are everywhere from cereal, toothpaste, applesauce, and cough syrup. The uses of food coloring has 0 nutritional value. It essentially is for look. So one use is for the color of food for people to help identify freshness. For example, associate green with mint or blue with berries. It's used to enhance, so enhance processed food. Processed food lacks color because during the manufacturing process, it strips away the natural color of food. And so to make up for that, manufacturers add in the dyes. So many yogurts that we are feeding our children are actually white, but they dye them to make them look more appetizing. They're also used for preservation. So for example, most pickles that you see in the grocery stores are actually green, but over time the pickles will start to turn yellow. They add the food dye in to prevent them from turning yellow. And one study found that on average, a child consumes anywhere between 100 milligrams and 200 milligrams of food dyes a day. And so this means that every day kids in this country are essentially drinking 2,000 gallons of food dyes a day. Here are some popular products that use food dyes, and this is not even scratching the surface on products that use food dyes that are sold in American grocery stores. In fact, one research study collected products and food color information for about 110 products in one grocery store. This study was done in 2014. And what they found was that overall 350 products, so 43%, contain synthetic food dyes. The most common food dyes were red number 40, blue number 1, red number 5, and red number 6. Produce was the only category that did not have any synthetic food dyes. But the food categories with the highest percentage of products containing food dyes included candies at 96%, fruit snacks at 94%, and drink mixes and powders at 89%. And so the daily amount of dyes certified by the FDA, so the FDA's ADIs, has increased fivefold from 12 milligrams to 60 milligrams. So they're upping the amounts that they're saying is okay to ingest. So one study shows that a child may be consuming easily 100 milligrams a day. So this is where regulation needs to come in, is that if the FDA is increasing their ADIs, but the studies are showing detrimental effects at a much lower milligram intake, and children are ingesting more than that, at least 100 milligrams, this is where the regulation needs to come in and place warnings on products, or do some really heavy regulating on what it is that the food companies can be manufacturing. And it's really interesting because a lot of these, as we discussed when we were talking about Great Britain and Europe, a lot of these food companies are already making products with natural food coloring in them. They're just selling them overseas and not here because we are not regulating them heavily like they are in Europe. So not only are food dyes used in our foods, but they're also used in everyday household things, toothpaste, medications. So this slide shows pictures of common medications, over-the-counter medications for children. A lot of companies do make dye-free medications, but you either need to read the back of the label or it'll say dye-free on the front of the label. I did place a picture of Vyvanse on here because Vyvanse and Ritalin do use food dyes in their prescription medications. Please do not stop giving your child medications because of this information. It's very trace amounts that's used in it. I just found it very ironic that an ADHD medication has food dye in it. At this point, you might be thinking to yourself, okay, this is a great history lesson, but how does this pertain to my child or a child with ADHD or adverse behaviors? Well, now we're going to get to the nitty-gritty of what the science is saying about the potential neurobehavioral effects of synthetic food dyes in children. So, in 2021, the California Children's Environmental Health Center, the Office of Environmental Health Hazard Assessment, and California's EPA published this very thorough assessment of what the research is saying are potential neurobiological effects of food dyes in children. And so how they came up with this publication is they compiled all the literature out there, all the clinical trials and all the assays specific to neurobehavioral effects of children who ingest food dyes. What is the science saying in the publication of the Office of Environmental Health and Hazard? Well, in a summary of human studies, about 64%, so 17 of the 27 studies, found positive associations between food dye exposure and neurobehavioral outcomes. The publication also stated that sensitivity to synthetic food dyes varies greatly from person to person, and some children are likely to be more adversely affected by food dyes than others. The publication also stated that most studies involved in administering multiple dyes at the same time, so no single offending dye could be identified. And then this one's very interesting. As many as 8% of children with ADHD may have symptoms related to food dyes. So that's roughly 500,000 American kids who have been diagnosed with ADHD who may be affected by food dyes. And when you think back to the prior slide of the societal cost of ADHD, and you think that as many as 8% of the children may have symptoms related to food dyes, it makes you wonder if that societal cost could decrease just through a healthy whole foods diet and the elimination of food dyes. The publication also talked about a study done in the Netherlands of children whose ADHD symptoms were drastically reduced after following a few foods diet. So what they did is they completed brain scans, and this is the only study to have completed brain scans on children with following ADHD and food dye. And what they found was that after following the few foods diet, there was an increase in activity in the area of the brain that is connected to the cortex. So that essentially resulted in higher functioning. So the cortex is the part of the brain that's responsible for memory, thinking, learning, reasoning, problem solving, emotions, consciousness, and functions related to your senses. So in finding this, researchers in the Netherlands have for the first time shown a positive relationship between a decrease in ADHD symptoms and an increase in brain activity after the diet. And remember, an increase in brain activity is a good thing. And so when you have ADHD, you have a lower brain activity in that area, and when you take Ritalin or a medication, it increases the brain activity in that area. So what this study shows is that they're having the same effects of increasing that brain activity in that area through a few foods diet, just as medications do for ADHD. The publication states that in animal studies, they're able to look more closely and in depth on the effects by providing data indicating exposure to synthetic food dye, really specifically relating to brain activity, memory, learning, and changes in neurotransmitters. They're also able to look at brain histomorphology, so if there's any change or effect on the brain after exposure to food dyes. And what these animal studies showed was that, in fact, there were changes to brain chemistry and histomorphology after exposure to several food dyes, more specifically to red dye number 3, number 40, and yellow dye number 5, and yellow dye number 6. And so looking more closely at some of those studies, in one study of yellow number 5 in rats, it was discovered that more days were required for the rats treated with yellow number 5 to reach the learning criterion to complete a maze. And they found that those rats also made more errors during that learning process and during the retention phase of those dye-treated rats. They also found alterations in the number of cells in the brain, in the volume of the brain, and in those cell shapes of the brain in the prefrontal cortex. In a study on rats with red dye number 40, those rats that were dye treated showed more errors in reference and working memory. They also found the volume of the medial prefrontal cortex was smaller in those red dye dosed rats than in the control group rats. They also found fewer neurons and glial cells in this brain area. So again, when you think about the brain signaling from the gut to the brain through that GI tract, they were finding fewer neurons, so fewer serotonin synapses in those red number 40 dye-treated rats. Here are what some other publications and researchers are saying. So the American Academy of Family Physicians has been persuaded by the accumulating data on the neurobiological effects of food dyes on children And they have stated that, quote, studies have shown that certain food colorings and preservatives may cause or worsen hyperactivity or hyperactive behavior in some children. Talk to your doctor about whether you need to make changes to your child's diet, unquote. Another statement that was made in the Diagnostic and Statistical Manual of Mental Disorders, published by the American Psychiatric Association, cites two of the recent reviews stating, quote, a minority of cases of ADHD may be related to reactions to aspects of diet, unquote. In another 2014 review approached by the issue using guidelines developed by the Oxford Center for Evidence-Based Medicine to examine different non-drug treatments for ADHD. So if you look at this figure here, they have a rating of each specific treatment regarding ADHD, and they give artificial food coloring exclusions and restricted elimination diets a 4 out of 5 in treatment for ADHD. Now, please keep in mind that it's used with neurofeedback and family therapy, and that they do actually, the best rating of 5 out of 5 for treatment is through FDA-approved medications, through supplements, and through school-based interventions. So please do not think that a restrictive diet is a kind of one-size-fits-all or an end-all be-all. I think it's important to remember that this could just be a tool that you use, or, you know, a lifestyle that you follow in addition to other treatments. So you might be thinking, gosh, Bailey, this presentation sure has been meek. But let's be positive here and optimistic, because not only do we already know that you can change the microbiome in your gut by providing healthy foods, which is very positive because we are in control of that. But many food companies are making products without food dyes in them. So I placed Honey Nut Cheerios on here, Goldfish, which I was very surprised Goldfish doesn't use food dyes, and Annie's Fruit Snacks. These are, again, just a couple examples. There are many more out there. And then on the right side of this slide is food dye honorable mentions. So a lot of these companies have begun either eliminating dyes from some or all of their products. And so here's a list of different fast food places, different food companies, and also a grocery store, Aldi. Shout out to Aldi. I love Aldi. So they are eliminating food dyes from some or all of their products. So this is from the Center of Science for Public Interest, the honorable mentions list. So I think it is important to also shine light on the positive side, that this is becoming noticeable. Companies are doing something about it. And to remember that ultimately we have a choice in what we feed ourselves and what we feed our children. So what can you do? I think first, if you're wanting to do a dye-free or eliminating diet, you should talk with your child's doctor. I think if you're concerned that food dyes are having adverse effects on your child, keep a journal and document the behaviors your child's exhibiting after consuming those synthetic food dyes. I think this third bullet point is probably the most important bullet point. As we looked at earlier, all across America, children are not getting enough fruits and vegetables in. And so I think instead of focusing on food dyes alone, you should be putting more of an emphasis on eating more whole, healthy foods. By doing this, you can shop the outside of grocery stores. So what I mean by the outside of grocery stores is the outer aisle of grocery stores. Once you start shopping the inner aisles, that's when you get into the processed food and food dyes. You can also read labels. I just become knowledgeable and aware of what ingredients are being used in our foods. To kind of piggyback off of that, research. Do your own research, stay up to date, stay knowledgeable. Get the whole family involved. I think this is another important one. Should you decide to go dye-free, I think it's important that the entire family goes dye-free rather than just, a single child or just the child. Have less processed snacks on hand and less processed quick fix foods. We don't have a lot of time these days, it feels like, but I think making the time to cook a healthy whole meal will really, really make a difference. And lastly, should you go dye-free, inform the schools and your family members so everybody's on the same page.